All right, welcome everybody to the March 1st OpenShift Commons briefing. My name is Paul Morie. I'll be your host today. I have with me Yuri Tsarev from Absa Group, and he is going to talk to us today about the Kubernetes global balancer. So why don't you take it away, Yuri?
Hi, thanks a lot, Paul. So I'm Yuri, I'm principal engineer in Absa, and I'm part of the platform engineering team, and we are mostly focused on building advanced automation on top of Kubernetes. And one of the open source projects that we produced in 2020 is the Kubernetes Global Balancer. Roughly around the concept. Guys, do you hear me well?
Yeah, we can hear you.
Yeah. Sorry, there was some.
Go ahead.
Yeah. Thank you. This project is originated out of the need of global load balancers that is Kubernetes native and pretty much cloud native. So we tried multiple vendors, none of them worked for us well. So we decided to develop one load balancer from scratch. But this load balancer is not a standard approach for load balancing. It doesn't pass the traffic through itself. It actually modifies DNS responses on fly, and it monitors the Kubernetes primitives from inside the cluster. So it is developed as an operator pattern, like it's coined from CoreOS back in the days. It doesn't have any single point of failure, so a controller is installed on top of the target clusters where workloads are running, and there is no control cluster, so there is no single point of failure in that regards. And everything is built on top of standard Kubernetes primitives, ingresses, services, associated endpoints, and down to liveness and readiness probes. So the core of the operation is the DNS protocol, and as it's running internet, it's pretty reliable. It obviously has its own limitation, but for global balancing scenario, it works pretty good. And we try to build the K8GB this way, so it's as much independent of environment as possible. So meaning that we relying on environment DNS, for example, we call it Edge DNS. It's Route 53, for example, or Infoblocks in our on-prem scenario, or NS1. As we have another integration. So we are configuring only DNS zone delegation on environment DNS, and the rest of the DNS responses are served dynamically by K8GB itself. So from implementation standpoint, we use the operator SDK, and it worked very nicely for us, and it allowed us to bootstrap project pretty quickly. Another integral part of K8GB is core DNS. That's exactly the tiny part that serves the DNS and responses dynamically and basically steering traffic to desired clusters according to the load balancing strategy. External DNS is taking care of communication with external DNS with HDNS providers, as I mentioned. So it's as a Route 53, NS1, Infoblocks, and maybe something else in future. So these three we already very well tested. So this part takes care of automated zone delegation. And we also were using etcd, like dedicated etcd cluster and associated etcd operator to actually populate local etcd database dynamically. So external DNS would read information from dynamically populated DNS endpoint CRD, and external DNS would locally create the etcd entries. So and eventually core DNS would read from this etcd, it's so-called Cascade DNS backend. So it worked like out of the box. We utilized community procedure here, but it had quite amount of reliability and maintainability problems. So for example, etcd operator is dropped by community completely, etcd itself, and it wasn't working reliably enough. So long-running clusters, we were finding etcd in a degraded state from time to time. So it was a problem for K8GB reliability itself. So that's why in a recent version we dropped etcd and etcd operator completely, and we replaced it with a core DNS build with a custom Kubernetes CRD plugin that we developed recently. So core DNS, in our case, can read information directly from DNS endpoint. I will show everything like in a demo how it works. So now we can create this dynamically morphed DNS responses with information out of DNS endpoint CRD directly from communication of core DNS with basically Kubernetes API, bypassing unnecessary layer of etcd operator, and it made the whole setup much more reliable. And everything is driven by a single CRD of GSLB type. So we have quite amount of integrations. So these HDNS providers I mentioned. So Infoblox we heavily testing, like not testing, we're using in the bank. And that was the first provider we implemented, so to fulfill our business needs. Route 53, we using AWS reference setup that I will show you today on top of two geographically dispersed EKS clusters, and NS1 as our future integration. We are very close collaboration with these guys, they are amazing. And we have very nice open source cooperation with Admiralty project, which is multi-cluster scheduling, and it works very nicely where Admiralty schedules workloads on top of multiple clusters, and KGB basically enables a load balancing for them. So we have a associated tutorial for that on both of the pages of both of the project. So you can quickly go to the demo. So just quickly on a project website, so it's KGB.io and associated GitHub, obviously. So just to provide a context between the demo, so we will run two EKS clusters.
Yuri, it might help if you just bump the font size up or zoom in on that picture a little bit.
I'll try. Is it somehow better?
There we go. There we go.
Cool, cool. Thank you for that. Up. Yeah. So we will run a demo setup similar to the picture here. So two geographically dispersed clusters. One is in Europe and Dublin, another one in Africa, Cape Town. And on top of both clusters, KGB is already pre-deployed, and there are some sample workloads, and we will work with GSLB, customer source definition. And customer source definition pretty much works, looks like that. It's on the index page. So we have a kind GSLB, obviously our special API, and we have embedded ingress resource type. So basically, it's kind of the same ingress spec as a standard Kubernetes one. It's actually behind the scenes, under the hood, it's exactly the same Golang type, and we embed it into GSLB. And we specify the pretty standard rules, also host and backend service. So, and the controller will be monitoring its healthiness. And on top of that, we attaching, we adding the specific load balancing strategy. So let's go straight to the demo, I guess. Is my console visible? All good?
It's visible to me, yeah.
Cool. All right, so what we're running here. So two clusters, as I mentioned. We'll check with get nodes the geographical locality. Okay, and I'm surprisingly logged out. Sorry for that. Sorry, token just got expired. Wasn't very lucky. So yeah, we are in Europe. The second cluster is in a Cape Town. So we see it by this text, right? In a node names. So And on the right pane, we just running continuously this stuff. It's just a demo script which continuously polling the associated FQDN. So it's just while true, right? And it grabs the message because it can the sample application contains a geotag to actually demonstrate where it's located. So it's super simple. So we continuously pulling it. Currently, everything is healthy and located in Europe, as we can see by geotag here. So let's investigate the testing setup. So first of all, how K8GB setup looks like. So controller itself, core DNS, and external DNS, which is taking care of Route 53 side of configuration. So effectively, zone delegation. So so as you can see, pretty minimal footprint as of now, especially after we got rid of etcd operator and etcd special etcd cluster part. So for testing workload, so we are running in test GSLB namespace, a special workload, which is like standard pod info, which exactly returns this response with a geotag. And we have GSLBs. So this special GSLB failover one, which is actually deployed out of this spec, which is very similar to the one that I showed on the index page. So again, failover, test K8GB IO as a main host, backend service, which we are running in a testing namespace of test GSLB here, and failover strategy. And we are pinning European cluster as the main one before the failure occurs. So in case of some malfunction, it should be failed over to African one, to Cape Town. So in runtime, it looks like this. Yeah, but better to specify. It's fully with the status. So it detects that the service is healthy. The one that is running in test GSLB namespace. The one that is front-end pod info, and the one that is referencing embedded ingress spec, right? And it populates the DNS endpoint with the IP addresses of a load balancer associated with the workload ingress. So if we will get ingresses, and specifically test GSLB failover, we will have in a AWS setup that we are running associated NLB. So if we dig this NLB, you will see these addresses, and that's exactly the ones that are getting populated in DNS by K8GB. So we pretty much can dig right now, and they are identical. So basically, currently, workload is running, and we are pointing to European cluster. If we go to Cape Town, so just to verify that we are in Cape Town, we are in Africa, we will see that we are running exactly the same setup. So without any modification, it's the same spec. And both clusters are returning consistent responses. So as you can see, this African cluster also returns a DNS response, which consists IP addresses of European cluster where workload is healthy, and which is labeled as a main one.
Yuri, so, a question that I thought of looking at this. How does the geotag field of the status get computed?
Yeah, so geotag, it is specified at the very beginning of deployment of the cluster. So for example, if you look in a European K8GB configuration, right, it's basically Helm values. So we specify in geotag, and we specify geotags to talk to. And in case of African configuration, we're doing exactly the same, but vice versa, right? Cluster geotag is the ones that we label the cluster with, and external geotags to talk to is European one, so we swap them, and the rest is created by convention. So zone delegation, NS servers names, they are all consistent geotag and zone, and basically clusters out of this geotagging, they know how to contact each other through this conventional FQDNs. And that's how they basically sharing the information, also through DNS protocol.
Got it. Thank you.
Cool. So we can actually go to the European cluster and try to emulate the failover. So we can do it simply by, as we usually doing it by scaling, right? So of deployment, so testing deployment for input info, and we scale it to 0. So what about to happen? GSLB should detect unhealthiness with the next reconciliation loop. So as you can see, the limitation of DNS protocol. So we're running like DNS DTL 30 seconds. We're also running some reconciliation loop on top. So there will be some 5 or 3s during the failover. Let's see how fast it will happen. So reconciliation loop already done. So basically, it already ready to return African IP addresses, and basically failover already happened. So it was pretty quickly. So what important to pretty much repeat, but in a failover scenario, that again we have exactly the mirrored resource in Africa, and it also returns again the uniform response. Right now it took over, and both European and African clusters are returning African Cape Town IP addresses of this load balancer, and basically both of them are steering traffic to Africa because workload in Europe is dead. So everything looks great and as expected. So we are getting African geotag as a response. So we pretty much can scale it back in Europe. And see how it will return back to the master cluster. So next reconciliation loop, it should pick it up.
While we're waiting for that to happen, here's another question. What is the highest number of clusters that you've used the global balancer with so far?
Well, we always using it in pair, right? So we even have a ticket like to test it like with more than 2, but so far all the testing was done with 1 pair. Gotcha. We have a multiple pairs, like we're running around 122 clusters, and they're K8GB enabled, but they always like in this pair. So we never properly tested it for example, for 3 clusters or 4 clusters enabled. Not yet.
Gotcha.
We definitely have it in the backlog. Yeah.
Yeah, understood. I think this is a pretty new project, right? How long have you been working on this?
Well, it started in December 2019, so it's like slightly more than 1 year.
Okay.
Yeah, and it is already heavily used within Absa. So we're running it in production for several projects, and more teams are adopting. So yeah, obviously finding new issues and challenges on the way. So for example, currently we are thinking how to actually handle multi-tenancy. Usually our clusters, as like we are controlling them with a rancher centralized way, so there is no problem to spin up a new pair of clusters for a team and they will fully own it. But sometimes we need a multi-tenancy and K8GB is actually not ready for it, right? And by the way, yeah, it failed over back to switch back to the main cluster. So now we are in Europe, so everything is expected. Yeah, so, and we have, like, if we go to the GitHub, we have pretty much good activity. We're using GitHub issues as not just like reporting bugs, but also doing a milestone. So we have quite a amount of plans. Outstanding ones, for example, is how to implement more complex strategies. So currently it's a failover and a round robin. I can quickly show you round robin. Yeah, so basically it's pretty much the same. Here in this example, we just operating several applications, several services in backend, right? So just to demonstrate the statuses like non-existing, unhealthy, and front-end, which is healthy already, and a round-robin strategy. Yeah, this one are additional controls over the specific stuff like DNS-TTL, for example, if you want to make it shorter or longer. So it's all available. Yeah, and for actually, I can show the round-robin runtime. We should have this GSLB around. Yeah, so round robin is basically merging the array of IP array of both clusters, right? And basically making them standard DNS round robin out of two clusters. So as you can see, and again, if we scale, so if we emulate yet another failure, it should return only half an array and then return back. So while it's converging, yeah, so the next step for us would be figure out how to implement more advanced load balancing strategies. Like we do not have a urgent business need for that. Like these two reliable strategies are pretty enough as of now for us. But from community standpoint, we definitely want to implement something like more interesting, like geographically, where geographically like returns the closest DNS response, for example, closest to the requester and all that stuff. So we are thinking of idea of writing some advanced custom for DNS plugin, which is like aware of situation more and can modify DNS responses on the fly. Because currently it is nice, it can do its job, but it's pretty much if you get to these DNS endpoints, right? That's how it works in the backend. The controller dynamically populates this DNS endpoint CRD, this kind, and DNS reads it. And according to the strategy, it populates with a specific IP addresses. And obviously, it has its limitation. It's enough for basic load balancing strategies, is one I demonstrated, but it's not enough for something more advanced like weighted load balancing or again geographical locality, because it's not enough dynamic here, right? Mm-hmm. So
is there a particular strategy that you heard requests for many times from community folks?
Well, not yet. So we are not like, we are still a little bit under radar, right? So there is no yet direct response, but it's very nice that Red Hat actually initiated some conversations, so and willing to contribute. So Rafael, you probably know him, a very nice person. He approached us with a very technical question regarding K8GB, and it looked like we are going to have very nice collaboration in regards of integration to OpenShift. So yeah, looks very promising. And we definitely have some plans regarding strategy. So if you pretty much look in the issue, so we want to add the topology, some manual, weighted, and consistent round robin, because currently it's pretty much random. So yeah, we have this plans in mind. But so far, we heavily worked on API stabilization and overall reliability of solution itself. So many enhancements in the management, for example. So to ease the adoption by teams, we implemented like a backward ability to create GSLB strategy with a simple ingress annotation. I think it's better to show in a documentation. So if we go there, yeah. So one of the main goals of KGB is actually to give development team a power over load balancing, right? So instead of standard HTTP checks, we utilizing pod probes, which are defined by application teams. So, and the strategy is describable by a simple CRD. But sometimes, like, it's a little bit overhead to add yet another CRD into Helm charts, and we have multiple teams. So that's why, and it was also a community request from Admiralty project. We added ability to add the specific KGB annotations on top of standard ingress. A controller with the same information as we specify in the spec. So like strategy type and geotech in case of failover. Controller would pick it up and create GSLB automatically for this specific ingress, reference it, and we'll close the loop this way. So basically, application teams are even not required to control yet another CRD. They can pretty much utilize a standard ingress with a couple of additional annotations, and the global load balancing will work for them. Controller will take care.
There's a question in the chat about whether K8GB has been submitted at all to CNCF, or is that on the radar? Is that on the roadmap?
It's totally on the radar, yeah. I really want to submit it to Sandbox as soon as possible. Like, it's really good question, yeah. We have a like in direct plans.
All right.
We are just getting ready with a little bit stabilization. So I think we are pretty much tested currently, like both internally and a little bit by community. So project is pretty good shape. So I think it's ready for Sandbox.
If folks want to get involved, I'm sensing that the GitHub repos are the best place. Is that accurate?
Yeah, totally. So we doing everything in GitHub. For KGB. So again, GitHub issues I use not just as issues, but as also anything, future request, roadmap planning, and anything. And obviously, pull requests are welcome. And feel free to shoot an idea. Yeah. And for chat, we are hanging out in a SIG multi-cluster in a Kubernetes Slack. So you can find us there as well.
Diane, I see you have a question in the chat. Why don't we take that one offline?
Absolutely, yeah. I was trying to figure out who's working on this besides Absa. Is this just coming out of Absa, mostly contributing this project?
Yeah, so it's coming out of Absa, but we are trying to gather community. And as I mentioned, we already have a very nice conversation with Red Hat, and looks like Red Hat will join, and we are very happy about this fact.
And there's another question.
All right, any other questions?
Yeah, Vipin is asking, how is this different from F5 CIS because they're using F5 CIS?
I'm not sure if I'm familiar with CIS, but generally, how it's totally different from any kind of standard load balancer. So the two things. So it doesn't pass the traffic through itself. It utilizes, it basically works purely over DNS, and it is aware of internal cluster resources. So it doesn't employ any standard HTTP checks. It uses pod liveness and readiness check to make a balancing steering decision. And it's totally open source. Hopefully it somehow answers the question.
Yeah, I know we have a built-in load balancer, I believe, for OpenShift now. So is this would this replace that, Paul? Or how?
I think you're referring to the router.
Yeah.
I don't think that I have enough information about what's been discussed to comment about that.
Well, I look forward to seeing it in the sandbox and getting some more folks and more Red Hatters working on it and seeing it again in action and integrated into OpenShift. And a demo of that sometime soon. That would be awesome. So
that sounds great.
Yeah, maybe we'll have a sequel to this one sometime soon.
Yeah, that would be great.
All right, let's see. Any other questions in the chat?
If not, what I'd have you do, Yuri, is go back to your home page there for your project for K8GB.
Yep.
And it's so close to KGB. I'm going to have to keep myself from saying that.
Yeah, we have the same problem.
That's not bad. And then I would say this is where people can go as well to find more information, or as you said, Yuri, the SIG cluster, the CNCF SIG cluster SIG is
SIG multi-cluster.
Yeah, SIG multi-cluster. It would be a great place to find you all, and I look forward to seeing it used in at scale in production and getting some more feedback on this. I think it's going to be a great addition. A great addiction, I almost said, addition to the CNCF and to just to the open source communities. This is really a very, very interesting project. So we'll be definitely following it along closely.
Thank you so much.
Well, thanks for joining us, Yuri. And just one thing, I think that was Kubernetes SIG multi-cluster.
Yeah, it was.
All right, great.
Yeah, so basically I'm utilizing your Slack channel, guys.
Yeah, that's okay. That's good.
That's what it's there for. That's perfect. All right. Well, it's great to hear from the Absa group, and looking forward to hearing more great things. And this is the beauty of open source. So thanks, Yuri and Paul, for having us today.
All right. Thanks.
Thank you so much.
Talk to everybody soon. Bye-bye.
Bye-bye.
Thanks a lot.